Hey everyone! Welcome back to our chemistry lesson with me, Teacher Tisha. Today we are going to take a look at the chapter Chemical Formula. In this chapter, we are going through all the formula and calculation parts. So, make sure to take note of all formulas and focus on the calculation part so that you won't miss anything important in this chapter. Now, without wasting our time, let's get into our lesson. Chemical formula are representative of a chemical substance with alphabets to represent atoms and subscript numbers to indicate the number of each type of atom that is present in the substance. There are two types of chemical formula, which are molecular formula and empirical formula. The molecular formula is the actual number of atoms of each element that are present in a molecule of the compound. And the empirical formula is the simplest whole number ratio of atoms present in a molecule of the compound. Let's take a look at the example here. Phosphorus pentoxide has a molecular formula of P4O10 and empirical formula of P2O5. The molecular formula that represents the molecule has been divided into two to make the simplest whole number ratio, which is the empirical formula. Now, we are going to look at the example of how to calculate the empirical formula of a molecule. Here, the question said that a 0.32 gram of metal X combined with a 0.36 gram of non-metal Y to form a compound. And what is the empirical formula of these substances? So, the first step that you need to do to conquer this question in exam is by preparing a table first, like shown in the example here. Then, you need to write the mass of each element in the first row. Then, for the second step, you need to find the number of moles of each atom by using the mass and molar mass given in the question. Then, from the number of moles you get, make sure you divide the moles with the smallest number to get the simplest number ratio of atoms, where for this example, it is 0.005 mole. And for the last step, you need to calculate the simplest mole ratio of atoms and write down the empirical formula. Do you guys know that the atom is very tiny and it's very possible to weigh it directly? So, to determine its mass, we need to compare it with a carbon-12 atom, which is a standard atom. Now, we are going to look at the meaning and formula of RFM, RMM, and REM. RFM, known as relative formula mass, is the mass of a unit of ionic substance when compared with 1/12 mass of carbon-12 atom. And the formula used to find RFM is the average mass of a unit of the ionic divided with 1/12 mass of a carbon-12 atom. Next, RMM is known as relative molecular mass. It is the mass of molecule when compared with 1/12 mass of carbon-12 atom. The formula used to find RMM is similar to RFM, but we use the average mass of a molecule instead and divide it with 1/12 mass of carbon-12 atom. Next, REM is known as relative atomic mass, and it is defined as the mass of an element when compared with 1/12 mass of carbon-12 atoms. The values of REM of elements can be obtained from the periodic table. For example, here we have an oxygen element. As you can see here, the atomic mass of oxygen is 16. So, the relative atomic mass, REM, of oxygen is also 16. Next, let's take a look at the formula that are frequently used in chemistry. There is a three way you can use to find the number of moles. You can use the number of particles, divide with the Avogadro constant, or you can use mass and divide with molar mass. And also, you can use the volume of gas and divide it with molar volume. Let's take a look at the example for each formula. In example 1, the question asks to calculate the volume of 2.2 mole of hydrogen gas in dm cube at standard temperature and pressure known as STP. So what we have to do is we take the number of moles given in the question, which is 2.2 mole, and times it with the molar volume at standard temperature pressure, which is 22.4 dm cube per mole. But if the question asks to find the volume at room temperature, you have to use the molar volume at room temperature, which is 24 dm cube per mole. Now moving on to example 2. The question states to find the number of moles of 6 dm cube of oxygen at room condition. So we have to take the volume of gas given, which is 6 dm cube, and divide it with the molar volume at room temperature, which is 24 dm cube. Next, for example 3, we are going through the mass calculation. We are going to find the mass of nitrogen gas when the question gives you the volume of the nitrogen gas. So the first step in mass calculation, you need to find the number of mole first. We can use the formula volume over molar volume in this case because the question only gives us the volume of nitrogen gas. So we take the volume of nitrogen gas, which is 6 dm cube, and divide it with 24 dm cube per mole because the question states that the volume given is in room condition. Then, after we get the number of mole, we can use it to find the mass of nitrogen. We can use the formula number of mole times with molar mass. So now, take the number of mole that we already find, which is 0.25 mole, and times it with molar mass of nitrogen gas, which is 14 gram, but we need to times with 2 because there are 2 nitrogen atoms in nitrogen gas. And that is how you get the mass of nitrogen gas. In chemistry, we use the unit mole to represent the amount of substance. 1 mole is the amount of substance that contains the same number of particles as the number of atoms in 12 gram of carbon-12, or 6.02 times 10 to the power of 23 particles. Now let's relate this theory to example 4 here. The question asks how many atoms are there in 0.2 mole of magnesium. So the formula we can use to answer this question is by using the formula number of moles times with the Avogadro constant. So we take the 0.2 mole as given in the question and times with 6.02 times 10 to the power of 23 atoms per mole. And that is how we get the number of atoms in magnesium. But make sure to be careful with the unit in chemistry, okay? For Avogadro constant, make sure you use the correct unit depending on the question asked. If the question asks for number of particle, you have to write the unit of particle per mole. And if the question asks for the number of atom for an element, you can use the unit atom per mole. And the same goes if the question asks for the number of molecules, you need to use the unit molecule per mole for Avogadro constant value. And that is the end of our lesson this time. I hope you understand this topic and take down some notes from our lesson. And I will see you guys in the next lesson. Thank you and bye!